Hi, and welcome back to the third video for section 5.3. In this video, we're going to be working examples dealing with period, phase shift, and amplitude. All the stuff we learned in 5.2. Hopefully you had a pretty good grasp of the concept. I know it was just real basic information, and when we work examples, hopefully you see how it can kind of all fall into place. You guys have heard the phrase, practice makes perfect. I cannot tell you how much practicing these kind of problems is going to simplify your life for the rest of the semester. You're going to see these problems on exam 1. You will see these problems on exam 2. You will see them on exam 3. You will see them on the final exam. So we're going to do 2 here. That's not anywhere close enough to call yourself an expert on graphing transformations of trig functions. So do the homework. If you need more practice, let me know. I can find other problems for you or write other problems up for you. But you want to practice these to get real comfortable with what you're doing. All right, so let's look at this example. We want to find the amplitude period and phase shift of the following equation. Y is equal to 3 sine of 2 times x minus pi over 4. So we want to find those 3 pieces of information and graph one period. You notice it says graph 1 period. It doesn't say graph 2 or 3 or 4. I'll see a lot of people, quite frankly, wasting time on exams by drawing a bunch of periods. You only need to give one period. Make sure you're only given what's asking for. On the exams, you don't have a lot of time to spare. So if it only wants one period, just give one period. All right, so let's get these pieces of information first. The first thing we want is amplitude. Amplitude is what? It's the absolute value of A, which is the value in front of our trig function. So that's absolute value of 3, which is 3. Remember, what is this talking about? It's talking about with our sine curve, how far above or below the middle line are we getting? So we're getting 3 units above or 3 units below at the lowest point. Period. So for period, we need 2 pi, because it's sine, over k. So what's our value for k? Well, our value for k is right here. It's 2. So it's 2 pi over 2, which is just pi. So remember from video 2 of this section, when we had pi, it means it shortened up how long it was taken to make a complete cycle. And lastly, phase shift. So phase shift is my value of B. It's the opposite of what I see inside the parentheses. I see minus pi over 4. So my phase shift is plus pi over 4. So again, remember from our base example, we had plus pi over 3. It moved everything to the right, pi over 3 units. Well, now it's going to move everything to the right, pi over 4 units. All right, so now let's get to graphing this guy. So we know it's a sine curve. So again, because of these transformations, we're going to label our 5 main points, which is 0, pi over 2, pi, 3 pi over 2, and 2 pi. Excuse me. If this was just sine of x, we could just draw it in right there with those points, but it's not. We have all this other information going on. So we need to take that into account. What's the first thing I said we do? Well, the first thing we do is divide by k. Our k is 2, so I'm going to divide everything by 2. So 0 divided by 2 is 0. Pi over 2 divided by 2 is pi over 4. Pi divided by 2 is pi over 2. 3 pi over 2 divided by 2 is 3 pi over 4. And then 2 pi divided by 2 is pi. And again, here's where we can stop ourselves. Do I have these numbers right? Well, if I have the numbers right, this is one complete period. It should take pi. Well, that's what I calculated the period to be, a value of pi. But now we have this phase shift. So we have to take all these values and shift them according to the phase shift. So I need to add the phase shift here. So I need to add pi over 4. Add pi over 4. Plus pi over 4. Plus pi over 4. Plus pi over 4. So 0 plus pi over 4 is pi over 4. That's this value right here. So I'm actually starting at pi over 4. So here's my 0 line. But remember, the phase shift is moving it, and it moved it over to where I'm starting at pi over 4. Pi over 4 plus pi over 4 is pi over 2. So that's this value here. Yeah, pi over 2. Pi over 2 plus pi over 4 is 3 pi over 4. So that's this value here. Let me write these in a different color so it shows up a little better. Do it in green. So this first one was pi over 4, then pi over 2, and then 3 pi over 4. And then 3 pi over 4 plus pi over 4 is 4 pi over 4, which is just pi. So that's this value here. And then pi plus pi over 4, so that's like 4 pi over 4 plus 1 pi over 4 is 5 pi over 4. So you can see we're going to be getting into fractions here again. If fractions are something that give you trouble, I would recommend practicing that a bit because you're going to use them here. I'm going to erase all my calculations here so we can sketch in the rest of the graph. So if you need to pause to get it down, go ahead. Okay, so the last thing is to draw. So we know it's a sine curve, but remember what happened. We have this amplitude change. So it's not just 1 unit up now, it's 3 units up and negative 3 units down. So we're starting at pi over 4. We get as high as 3 at pi over 2, back to 0, down to negative 3, back to 0. So our curve of 3 sine of 2 times x minus pi over 4 is the graph given right here. All right. So I'm going to move on to the next example. If you need to pause and take this in a little bit, please do. If you have any questions, make sure you jot them down in your notes. When you come to class, you can ask me about them specifically. Okay, so second example we're going to look at. Same idea, find the amplitude, the period, and the phase shift of the following. Y is equal to 2 cosine of 2x minus pi. So a couple things. First off, we're now dealing with a cosine curve. I know we've been dealing with drawing sine curves the whole time, and I don't want to get you in that bad habit where you're just always drawing sine curves. We have to pay attention to what function we have. In this case, it's cosine, so that's changed up. The other thing now is we have this 2 in front of the x, and I said we have to watch out for that. So the first thing we need to do is rewrite this equation, factoring out the 2, which means I have to divide this by 2 which means I also need to divide the other part by 2, so that if I was to distribute it back in, I ended up with the same thing. So I could really rewrite this as 2 cosine of 2 times x minus pi over 2. And again, you can see with the last part, if I multiply the 2 into both pieces, I get 2x and 2 times pi over 2, which is just pi. So it's still the original that I started with. It just looks a little different, but it's in the form that I need. So let's write down our information again. Amplitude. It's the absolute value of A, which is the absolute value of 2, which is just 2, and that's this one here. Hopefully all these 2's don't cause us a lot of problems. Period. So period for cosine is still 2 pi over k. Our k is a value in front of the parentheses, which is also 2. So that's 2 pi over 2, which again is pi. So as before with the last one, it's decreasing the period by half of what it was before. And then phase shift, well, I see negative pi over 2, which means my phase shift is plus pi over 2. So it's going to move everything to the right a distance of pi over 2 units. All right, so let's use the same methodology we used in the last problem. So I have my 5 normal points, 0, pi over 2. Now let me write these further down. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Step 1, divide by k. So divide by 2. 0 divided by 2, 0. Pi over 2 divided by 2, pi over 4. Pi divided by 2 is pi over 2. 3 pi over 2 divided by 2, 3 pi over 4. 2 pi divided by 2 is pi. Is that right? Yep, I calculated the period should be pi. And if I didn't do any phase shift at this point, that's where I would end up with, a distance of pi. But I still have this phase shift. I need to add pi over 2 to every one of these values, because they're all getting shifted by that phase shift, which is pi over 2. So 0 plus pi over 2 is pi over 2. So again, I'll write these up here in green. So our 0 line is back over here. So we would have been starting, because our amplitude is 2, up here at 2, and then making our sort of V-shaped curve. But now we're not. Now our starting point, if we want to write in this plus and minus 2, our starting point is at pi over 2 and 2 units up. So that's the start of our cosine curve. Then down here, pi over 4 plus pi over 2 is 3 pi over 4. So that's where our cosine curve comes down and crosses the axis. Pi over 2 plus pi over 2 is just pi. So that's this point here. I'm going to erase this top line right now. And again, it's coming down 2 units because that's our amplitude. And then 3 pi over 4 plus pi over 2, that's like 3 pi over 4 plus 2 pi over 4, which is 5 pi over 4. Again, if you need help with the fraction math, let me know. I can help you out. So 5 pi over 4. And then lastly, pi plus pi over 2 is 3 pi over 2. So let's back up here and then back up to 2. So the graph of what we were given to start, one period, would look something like that. It's our cosine curve, so that already looks different from our sine curve. Amplitude is 2, so it went up 2 units, down 2 units, and then the whole thing shifted over a distance of pi over 2. All right, that wraps up the 2 examples. We can certainly do more from the homework in class. Good luck.